Welcome back to another video, guys. Today we're going to talk about the topic of compressions. So, um, first, before we talk about it, let's figure out why are we even learning about it anyways, right? What are compressions and why do we need to learn about it? So we learn about how you can store, photos, images, audio using binary numbers, how you can store these type of files on the computer, right? Here in this subject, in this unit on compressions, we're going to learn how to reduce file size. So for example, I stored an image for 500 bits. Today, we will learn how to store this file for a smaller amount of bits. We're going to reduce the amount of memory required to store images. Now, the reason why we need to compress files is because, computers can easily run out of memory if you store huge files. So we invented this thing called compressions. So you can store images at a lower storage memory. It takes less memory to store the files. So what can be compressed? Basically, anything you store on the computer can be compressed. Videos, photos, music, text, lots of things can be compressed. All right, so without further ado, let's jump straight in. Um, there are two types of compressions we're going to learn about here. And one is called lossy and one is lossless. These are the two types of compressions that we will learn about. And they're quite different, but they are very similar in nature as well. And you can see about this photo here, and it portrays what lossy and lossless is. But all right, I'm not going to talk about these, go into detail about these. Jump straight in and talk about lossy compressions. All right. So lossy compressions, and first let's talk about what is a lossy compression. So we talked about a compression is a method we use to reduce file size, right? And lossy compression is a method where we can reduce file size, a specific method which we can reduce file size. The way in which this lossy compression method reduces file size is it deletes permanently deletes certain data from the file. And what data does it delete? The data that are normally unnoticed by humans. For example, if we have a piece of audio, violin playing, it will this lossy compression method will reduce the amount of memory taken to store this audio by deleting certain details in the music that you won't normally hear. So that is an example of lossy compressions. So it is a method of compression that reduces file size by permanently deleting data from the file that may be unnoticed by humans. And sometimes this last bit might not even exist. It is just reduced file size by permanently deleting data. So sometimes this last part doesn't exist, but sometimes it exists as well. So the nature for this is it reduces file size, it compresses the file by deleting data, right? And some examples of lossy compression formats. So the test will ask you about what are some examples of lossy compression formats. Uh, there is three prime examples: MP3, MP4. These are all lossy compression formats, and JPEG is also lossy compression format. So these three files are lossy compression formats. Now let's take a look at an example of lossy compression, and that is perpetual music shaping. We kind of touched on it before when we were talking about how you can use lossy compression to reduce the file size of audio. It's basically the same thing. It is a lossy compression method that reduces the size of audio files by removing details in music people normally won't hear. Right, so it's basically the same thing we talked about. We have a piece of piano playing, violin playing, anything, we just remove the small details that you normally won't notice. So that is what perpetual music shaping is. It is an example of lossy compression formats. It is, oh no, not format, it's a type of lossy compression that you can use. Yeah, so for here, the key thing to notice is remember this definition, of course. Remember that these three are types of lossy compression formats, and if they ask you to give an example of a type of lossy compression, just remember there's this thing called perpetual music shaping, right? Okay, now let's talk about lossless compression. So we talked about lossy compression. Lossy compression, it's you reduce file size by permanently deleting data. Here it is the exact opposite. You reduce the file size without deleting any data. But how do you do that, you say? How is it possible you reduce file size without deleting data? Well, lossless compressions use a compression algorithm to compress and reduce file size. Now, there are lots of types of compression algorithms. Now, a compression algorithm, right now, you just say it is a way to reduce file size without deleting any data. We're going to talk about one type of compression algorithm in IGCSE, and that is all you need to know for now. So, but for now, just remember that lossless compression, when you use this method, no data from the file is deleted permanently. All right, uses this thing called a compression algorithm. And PNG files, right, is a type of lossless compression format. So if they ask you to give an example of lossless compression formats, just say PNG. Now, this is very important. This thing called run length encoding. Um, this is a compression algorithm that can be used to do this lossless compression. So you can use this method to reduce file size without deleting any data permanently. So this is a compression algorithm. Very important, and we're going to look at how it works, and we're going to look at an example as well later. So first, let's take a look at the definition here. Run length encoding is a method of lossless compression which compresses a file by I wrote these 1, 2, 3s is because if they ask you to give a definition of run length encoding in the test, each 1 is a mark, 2 is a mark, and 3 is a mark. So keep that in mind. So run length encoding compresses a file, reduces file size by grouping together recurring patterns and storing the indexes for each group. And this compressed file has no data is lost. So compresses the file without any data loss. So no data is deleted from the file. All right. Sounds a bit interesting and wordy, but don't worry. We're going to take a look at an example, and then we're going to come back to this definition. So look at this problem here. If they want you to use RLE, run length encoding, to compress the following number, we're going to store this number in the computer. We're going to compress it. Take a look at the definition here. It does this run length encoding by grouping together recurring patterns. So the first thing you want to do is you want to find recurring patterns in the thing they want you to compress here. So here you will see that first there are 5 ones, right? And then there are 6 zeros, and then there are 3 ones. So now you grouped this number. So you want to first find the groups. And next, you want to store the indexes for each group. Now, what index means is how many of such things there are. For example, here the index is 5 because there are 5 ones. Here the index is 6 because there are 6 zeros. And here the index is 3 because there are 3 ones. And basically, you have done it. The completed RLE compression for this piece of number is 5, which is the index, followed by 1, because there are 5 ones. 6, because there are 6 zeros, followed by 0, because there are 6 zeros. And 3, because there are 3 ones, followed by a 1. So this is the number that you have changed this huge wordy number into. Easily changed into a simple number, 6-digit number, from this huge, disgusting number. So that's how RLE works. You first group the patterns or find the patterns in the thing you want to compress. Next, you want to find the indexes of each group and store the indexes for each group. And then you have completed run length encoding. And you will realize that no data is lost in this process. I can use this code that I've encoded, this number. I can change it back into this large number, and no data is removed or changed. So that's a good thing about run length encoding, and that is no data is lost. All right, a short session today. Hope you learned something from it, and I am constantly rooting for you guys to succeed. So, hope you enjoyed. I'll see you next time.